Satellite rocket performance. The performance of satellite rockets plays a crucial role in the successful deployment of satellites into orbit. Factors such as payload capacity, efficiency of fuel consumption, and accuracy of trajectory all contribute to the overall performance of the rocket. Engineers and scientists continuously strive to improve rocket performance through innovative designs, advanced propulsion systems, and precise navigation technology. The ability of a satellite rocket to deliver its payload to the intended orbit within the specified parameters is a testament to its performance. As the demand for satellite deployment continues to grow, so does the emphasis on achieving optimal rocket performance to ensure reliable and cost-effective access to space. Ongoing research and development efforts in the field of aerospace engineering are focused on pushing the boundaries of satellite rocket performance to meet the increasing demands of the space industry. A rocket is a vehicle that uses jet propulsion to accelerate without using the surrounding air. A rocket engine produces thrust by reaction to exhaust expelled at high speed. Rocket engines work entirely from propellant carried within the vehicle. Therefore, a rocket can fly in the vacuum of space. Rockets work more efficiently in a vacuum and incur a loss of thrust due to the opposing pressure of the atmosphere.